Water. Formula H2O, chemical name dihydrogen oxide, molecular mass 18 AMU. Introduction. 70% of Earth's area is covered with water. 2.5% of this water makes up the world's supply of fresh water, including the frozen water in polar ice caps and glaciers. Water exists in all three physical states as solid, as liquid, and gas. Water occurs in both free and combined states. Water has the ability to dissolve a wide range of substances and so is considered a universal solvent. Physical properties of water. Nature. Pure water is clear, transparent liquid. It is colorless, odorless, and tasteless. The taste is due to impurities present in it. Boiling point. Under normal pressure, pure water boils at 100 degrees Celsius. The boiling point of water is affected by pressure because boiling point of a liquid is considered as the temperature when vapor pressure equals to the atmospheric pressure. The boiling point of water also increases due to the presence of dissolved impurities in it. Freezing point of water or melting point of ice. Pure water freezes at 0 degrees Celsius under normal pressure. The freezing point of water decreases with increase in pressure. Density. At 4 degrees Celsius, water has its maximum density 1 gram per centimeter cube or 1000 kg per meter cube and minimum volume. Anomalous expansion of water. Water when cooled, it first contracts in volume, but below 4 degrees Celsius it starts expanding and continues so till the temperature reaches 0 degrees Celsius. The property of anomalous expansion of water enables marine life to exist in the colder regions of the world because even when the water freezes on the surface, it remains a liquid below the ice layer as the density of water is greater than the density of ice. Latent heat of fusion. The latent heat of fusion is the amount of heat required to change a substance from solid state to its liquid state at its melting point without any change in temperature. The amount of heat energy required by ice to change into water is called latent heat of fusion of ice. Its specific value is 336 joules per grams or 80 calories per grams. The same amount of heat is released when 1 gram is solidified. Latent heat of vaporization of water. The energy required to change water into its vapor at its boiling point without any change in temperature is called its latent heat of vaporization of water. Evaporation of sweat takes from the body, thus giving a cooling effect to the body. The same amount of heat is released when 1 gram of steam condenses to form 1 gram of water at 1000 degrees Celsius. It is on this account of high specific latent heat of condensation that steam causes far more serious burns than water at the same temperature. Specific heat capacity. It has been found that 1 gram of water when heated through 1 degree Celsius always absorbs 4.2 joules of heat. The fixed amount of heat absorbed by 1 gram of water when heated through 1 degree Celsius is called its specific heat capacity. Water, because of its high specific heat, is commonly used as coolant in motor car radiators, desert coolers, etc. Water as a universal solvent. Not only solids but also gases and other liquids dissolve in water. Hence, it is difficult to find absolutely pure water in nature. Water has a high dielectric constant. As a result, it reduces the electrostatic force of attraction between positive and negative ions and dissolves in even inorganic compounds which are usually electrovalent. Experiment to show that ordinary tap water contains dissolved solids. Procedure. Put some tap water on a clean watch glass and place it over a beaker containing water. Boil the water in the beaker. When all the water has evaporated from the watch glass, remove it from the burner and let it cool. Observation. On looking at the watch glass against light, a number of concentric rings of solid matter are seen. These are the dissolved solids left behind after evaporation of water. Importance of dissolved salts in water. Salts and minerals are essential for growth and development of plants. They add taste to water. They supply the essential minerals needed to the air dissolved in water. Of the two main components of air, nitrogen and oxygen, oxygen is more soluble in water than nitrogen. Experiment. To show that tap water contains dissolved gases. Procedure. Fill a round bottom flask completely with tap water and arrange the apparatus as shown in the figure. Observation. Gas bubbles are seen escaping from water. They are collected in the graduated tube by downward displacement of water. The water vapor present in the gases condenses on coming in contact with the cold water in the tube. Conclusion. The remaining gases come from the air dissolved in water and they escape on heating. Read the volume of the gas thus collected. The volume of the gas collected in the graduated tube shows the presence of dissolved gases in tap water. Importance of air dissolved in water. First one. Marine life uses the oxygen of the air dissolved in water for respiration and thus aquatic life is sustained. 1 liter of water contains nearly 40 centimeter cube of dissolved oxygen. Aquatic plants make use of dissolved carbon dioxide for photosynthesis. Carbon dioxide dissolved in water reacts with limestone to form calcium carbonate. CaCO3 plus CO2 plus H2O gives rise to CaHCO3 whole taken twice. Solutions as mixtures of solids in water. A solution is a homogeneous mixture of two or more components whose composition may be gradually changed, changing relative amounts of components. Solution equal to solute plus solvent. The medium of dissolution that allows one or more components to dissolve into a form of solution is known as solvent. The substance that dissolves in the solvent to form a solution is known as solute. A solution which is made up of two components is a binary solution. Solutions which are made up of 3 or 4 components are called ternary and quaternary solutions respectively. If the components exist in different physical states, then the solvent is that component which exists in the same phase as the final solution. If two substances are in the same phase, the component that in excess is termed as the solvent. A solution may be formed by mixing a liquid with another liquid, a solid with a liquid with a gas, a solid with another solid. A homogeneous solution of a solid into another solid is called a solid solution. Common metal alloys are solid solutions. A solution in which the size of the solute particles is about 10 to the power of minus 10 is called a true solution. Characteristics of a true solution. It is homogeneous mixture. The solute particles are very small. It is clear and transparent. It does not scatter light. Its components cannot be separated by filtration. The solute particles in a solution do not settle down. Dilute solution. It is the solution in which the amount of solute is rather less compared to the mass of the solvent. Concentrated solution. It is the solution in which the amount of solute is relatively more for a given mass of the solvent. Saturated solution. A solution that cannot dissolve any more of the solute at a given temperature. Preparation of saturated solution. Experiment. Take 100 grams of distilled water in a beaker, add 1 gram of nit and stir a glass rod till it dissolves. Add it continuously. It will also dissolve. Continue adding a gram of nit at a time and stir vigorously after each addition. A stage will come when no more nit will dissolve at that temperature. Then the solution is said to be saturated. Effect of cooling on saturated solution. The solubility of a solid usually decreases with fall in temperature. Thus, if the temperature of a saturated solution is lowered or if it is left open at a higher temperature for long, a part of the dissolved solute separates out in the form of crystals. The remaining solution is still a saturated solution, but at a lower temperature. Effect of heating a saturated solution. If a saturated solution is heated to a higher temperature, then it becomes unsaturated. More solute can be dissolved in this solution now. A saturated solution can also be made unsaturated by adding more solvent to it. Unsaturated solution. A solution in which more of the solute can be dissolved at a given temperature is known as an unsaturated solution. Supersaturated solution. A solution that holds more solute than it can theoretically do at a given temperature is called a supersaturated solution. Supersaturated solution is metastable, and slight disturbances like shaking, stirring, scratching the wall of container and adding a solute crystal to the solution make additional amount of the solution to precipitate out, thereby resulting in the formation of saturated solution again. Concentration of a solution. It is the amount of solute dissolved in given quantity of that solution. It can be expressed in many ways. 1. Mass percent. It is defined as the mass of the solid solute in grams present in 100 grams of the solution. It is mostly used when solute is solid and solvent is liquid. Concentration of solution equal to mass of solute by mass of solution into 100. Second one, volume percent. It is defined as the volume of solute in milliliters present in 100 ml of a solution. It is mostly used when solute and solvent are liquids. Volume percent equal to volume of solute by volume of solute plus volume of solvent into 100. Thank you.